afternoon. It's a tremendous honor and a pleasure to be here in Seoul. I'd like to thank Unicity for bringing me on board, and I'm really excited to share some of my knowledge about protein this afternoon. I'm going to tell you about protein, and as Dr. Bickman mentioned this morning, protein is a building nutrient. It's not a fuel. We're going to use it to build. I think it was mentioned that I come from McMaster University. McMaster is on the outskirts of Toronto in Canada. And these are the people that I'd like to introduce you to who are my students who have done the work that we're going to see here this afternoon. When we think about skeletal muscle, a way of thinking about it is that it's like a brick wall. We need to put bricks into the wall, and we need to take bricks out of the wall to keep it healthy, to keep it going. And that's what happens all the time in muscle. Protein is a nutrient that builds muscle. As we age, we lose muscle. And some supplements can also help build muscle. The processes that influence how muscle grows and how muscle is lost inside the muscle are numerous. And they include some very complex metabolic and biochemical systems. The output that we're looking for, however, when we're younger, is to grow muscle. And as we age, the output that we'd really like to see is that our muscle not decline as much. So we asked a number of people about the questions that were most important to them about dietary protein, which is an anabolic building nutrient. And they were the following. Does protein help you gain muscle mass with resistance training or weightlifting? Does protein supplementation aid in that process? If I eat more protein, will I gain more muscle? How much protein do I need? How does aging affect protein requirements? If I'm older, do I need more protein? Or do I need less? Are some protein supplements better than others? And finally, will protein cause my kidneys to fail, as you might often hear people say? So by the end of this talk, I'm going to answer these questions for you. First, we need to talk about muscle. Muscle is an important tissue. You heard from Dr. Bickman this morning that muscle plays an integral role in allowing us to move around, but it's also the single largest contributor to our metabolic rate, and it is a storage site for glucose, for our blood sugar. Muscle is like a brick wall, bricks going in, bricks coming out. The processes of muscle protein synthesis, or you'll see abbreviated on these slides as MPS, and muscle protein breakdown, work in constant opposition to each other with the meals that we eat that contain protein. So when we wake up in the morning and we eat a protein-containing meal, we see a large rise in muscle protein synthesis, bricks going into the wall. And we see a small decrease in muscle protein breakdown, or bricks coming out of the wall. And for a moment, we're getting a little bit more skeletal muscle, just for a small period of time. But then we don't eat, and until we eat our lunch, we don't experience another stimulation of protein synthesis. So you can see, in coordination with Dr. Bickman's 4-4-12 principle, really these breakfast and lunch meals need to contain adequate protein to stimulate this process, which is going to fluctuate throughout the day. Now, the situation is a little bit different when I've performed exercise. And the exercise I'm talking about in this situation is resistance exercise, strengthening exercises. In this situation, every time after we've eaten now, we get a greater rise in the amount of protein that our muscle is making. And we get a smaller loss of the amount of muscle that is lost during the fasting periods when we're not eating. Over time, this is why our muscles get bigger. We lift weights, we consume protein, and muscles get bigger over time. Or if we're older, muscles will get smaller at a slower rate. It's also, as this figure shows, after a bout of performing weightlifting, it's a long time in which protein becomes more effective. So it's important to remember, if you've done some exercise, the protein that you take afterwards is pretty effective for probably up to 24 hours. So this so-called anabolic window is open for a long time. The message I want to leave you with from this portion of the talk is that the increases in muscle protein synthesis and new bricks going into the wall and new muscle being made is long-lasting. And exercise potentiates that effect. A question that we asked a few years ago was, what was an optimal amount of protein to feed somebody in a situation to get their muscle to grow? And you can see from this figure, this is the rate of muscle protein synthesis and how much it changes in response to varying doses of protein, all the way from 5 grams to 10, 20, and upwards to 40 grams of protein. The rate, it appears, and it slows down and is at its highest, is at 20 grams of protein. But that's an average amount of protein for the person who was consuming it in this study. When we divide that out, we realize there's a range. So if you're a smaller person, you need less. If you're a bigger person, you need more. The value we came up with was about 1/4 gram of protein per kilogram per meal would stimulate muscle protein synthesis at its maximal level. And remember that number, because it will come back. So the message from this study was that 20 grams of protein were optimal to stimulate protein synthesis, or about 1/4 gram per kilo. We subsequently went on to do another study where we looked back at all of the studies and all of the people that we had tested over a number of years. And we conducted an analysis to see if that value still held. And you can see from this figure right here that a plateau in muscle protein synthesis happens, and this break point in the curve is at exactly the same value as it was in the previous study, or about 1/4 gram of protein per kilo. Now, the interesting part is this is how it works in young people. Young people who are very active, protein does a great job. So what changes then in older people? The interesting part is this is a comparison on the left between young people and on the right between older people. And you can see immediately that the point at which the curve tends to bend and the protein dose is larger in older people. Older people need more protein to get the same stimulation of muscle protein synthesis. And I think everybody here realizes that as we age, our muscles begin to get a bit smaller. We begin to get weaker. And so it would be a good thing and a good message to take back that as you age, your protein requirements go up. We refer to this as the anabolic resistance of muscle aging, and it looks something like this. So at this point, you can see that the effect of a protein-containing meal is attenuated in an older person. And this, over time, means that the gray areas of muscle loss are greater than the green areas of muscle gain. And older people lose muscle. One question then, when would our longest period of losing muscle? And Dr. Bickman mentioned this, and this is the 12-hour period when we're sleeping, because we're not eating. And when you're not eating, it means that your muscle protein balance is negative. So one of the strategies in particular with athletes, that we've used is a pre-bedtime protein meal. And it would be a great idea if this protein came from a pure and very digestible protein source. This figure shows you an interesting study from the Netherlands that shows that the amount of muscle that is gained by people who consumed protein prior to going to sleep is greater than those who consumed a placebo. Interestingly enough, at the same time, these individuals got stronger. So it's not just a muscle effect, it's a strength effect as well. So this is a strategy that we've used in athletes to tell them that a good regenerative strategy before they go to sleep is to consume protein. So when we talk to people who are quite active, we say to them, maybe a better way to consume protein is in maybe 4 meals per day. And one of those meals should maybe be before they go to sleep to offset this large loss of muscle that occurs during the overnight. So for gold medal athletes, for people hoping to get to the pinnacle of performance, we make the following recommendations. First, we talk about equally spaced protein-containing meals, 4 in a day, as opposed to the normally 3 that we consume. We talk about a larger pre-sleep meal. And the advantage of thinking about protein on a per kilogram basis like this is that we can begin to scale these to size. So for a large 120 kilogram American football player, this individual would require 204 grams of protein per day, or about 1.7 grams of protein per kilo. For a smaller female, 50 kilogram cross-country runner, she would require only 85 grams, but it works out to the same per kilogram body weight basis. So we've scaled protein requirements now for people who are very, very active. But dose and meal spacing are important. You can't have all of your protein at one meal and none at another. You should be getting protein at every meal. A question that we asked ourselves was, if protein is important, is it all of the protein, or is it just one single or a few amino acids? And the interesting answer, when you look at the literature and look at some of the studies that we've performed, is that it really comes down to a single amino acid, and that's leucine. Leucine is a branched chain amino acid, the concentration of which is important to stimulate muscle protein synthesis. It acts through a very complex pathway of proteins and biochemical reactions. And we now have a molecular mechanism for how this works. We know how to trigger this. And really, it's specific to leucine. So the leucine content of a protein would be an important determinant of how much muscle protein synthesis were stimulated. I'm showing you this figure because it's an interesting figure to make my point about how potent leucine is. In this experiment, we fed young men whey protein, 6 grams or 25 grams, or 6 grams plus 5 grams of leucine. And what you can see, looking at the far right, is the dark blue and the white bars are stimulating muscle protein synthesis to the same level. That's a dose of 25 grams of protein and only 6 grams of protein, but with added leucine. Leucine is a potent trigger for muscle protein synthesis. We've switched methods now, and we can now measure muscle protein synthesis instead of hours to days. So we can measure the amount of muscle that you gain while you sleep, while you're active, when you're eating protein, when you're eating a particular type of protein, when you're following a different diet. And this has been a large methodological advance in our understanding. And I'll show you two more experiments that really highlight how potent leucine can be. This was a study done in 72-year-old men, just to show you that the effect is as potent in older people as it is in young. What the graph in the middle shows you here is that when you add leucine to a meal, whether people are consuming a low-protein diet or a moderate protein diet, is that you get a stimulation of protein synthesis over days now. The other figure shows you the impact of exercise, which is always positive. The more physically active you are, everything in your body works better. You can see that adding resistance exercise, some weightlifting in here, stimulates protein synthesis. And yet adding leucine to that stimulates it even further. So we get an additive effect, and it works in older men. This next figure is in older women, again, about 74 years old, showing you that if you add leucine to the meals of these women, over a period of 1 week, they make more new muscle. Their rate of muscle protein synthesis goes up. If you add resistance exercise to this, you get an even greater effect. If you add leucine to that, you get an even greater effect. So we see the effect in young men and young women, older men and older women. It's very, very potent. So what proteins contain a lot of leucine? That would be an important question to answer. I'm going to show you a concept that we've worked on called the Leucine Trigger. And it goes a little bit like this. So we've got 3 doses of protein in this figure: a low dose, a medium dose, and a high dose. And you can see the trigger, the line that's across the graph, is only being met by the high dose of protein. Now, the interesting part, when you exercise, your muscle is sensitized to the effects of leucine. And this trigger comes down. And that's why we think that the two things add to each other. But if you are inactive, if you are older, if you are in a hospital bed, if you are sick, then the leucine trigger gets higher. And you either need to consume more protein or more leucine. This figure shows you what's called the leucine amino acid reference ratio. And it's a way of scoring proteins based on their leucine content. The orange and the red bar are from 2 whey protein isolates, the highest quality protein that we know of and present in a lot of Unicity products. The SPI A and B are soy protein. That's the yellow and the green bar. The blue bar is pea protein. The pink bar is white rice protein, and the gray bar is collagen. Simply said, this figure is showing you that the most abundant protein that we know of in terms of its leucine content is whey protein. I suppose the question you might be asking yourself at this point is, does any of this protein synthesis or anything really matter? So I'm going to give you an evidence-based answer. And evidence-based answers in science come from what we call systematic reviews of the literature. We look at all of the studies that have been done, and we try and take the answer from everything that's out there. So this figure shows you a screening process that we went through to isolate 49 different studies with 1,843 different individuals to answer the question of, does protein supplementation enhance the gain in muscle that people make when they lift weights? The simple answer to the question is that it does. Protein helps. It augments gains, as this figure shows, in strength, and it works really well in people who do more weightlifting. Not only that, but protein enhances gains in muscle mass. So you get more muscle and you get stronger. So this is the evidence-based answer that you can take back to people who say protein supplements don't help. They do. From the same analysis, we performed this same linear regression to look for the breakpoint in protein that would give you these effects. And the breakpoint that you can see here is 1.6 grams of protein per kilogram per day. That is 2 times the recommended allowance for just about every country that is represented in this hall today. That's an important message because it shows you that the recommendations for protein are probably a minimal level that you need, when in fact, you should be consuming twice as much. The confidence interval on this, which is the outer edge of where we think maybe the highest level might be, you can see from this figure is at 2.2 grams per kilo per day, which is very close to 3 times what is recommended. These are what we refer to as optimal levels of protein intake. Some important takeaway points, I think, from looking at this study. First of all, protein supplementation augments changes in muscle mass. Dietary protein supplementation was more effective in people who perform training. So you can't just go to the gym once, you have to go repeatedly to the gym. And finally, 1.6 grams appeared to be the intake above which you didn't see a lot more benefit in terms of protein, but it could be as high as 2.2. So these are some important points to take away. Finally, I'd like to tell you something about what protein will not do. We probably have heard more than once that proteins will cause our bones to get softer. And that's not true. Bone is actually almost 50% in terms of its content protein. It's made up of collagen. So it's not just calcium. It's not a stick of chalk. So we need protein for bones. And in fact, protein is needed for optimal bone health. But probably the biggest myth that you would have heard around protein is that it will cause your kidneys to fail. It puts strain on your kidneys and leads to kidney failure. I'm here to tell you today that that is untrue. This is generally how I explain it to people. First, I say there are no data that show that. An extensive review of the literature that we just completed and published this year shows no evidence for that. And in fact, when you look at the statements from the Institute of Medicine, who sets the dietary reference intakes in North America, they had the following to say: that protein content of the diet is not related to progressive decline in kidney function with age. If you don't want to listen to the Institute of Medicine, then perhaps you can listen to the World Health Organization. Here is what they say: there is no evidence that links the reduction in kidney function with age to protein intake. So 2 people, 2 different agencies, same analysis, and I'm here to tell you that this is a paper that we published, and you can see from the title, changes in kidney function do not differ between healthy adults consuming higher compared to lower protein intakes. So this is a review of all of the evidence that is out there. This is an evidence-based answer to that question. So it's important for you to take away that point. So the questions that I posed at the beginning of this talk are the following, and hopefully I've answered them for you. First of all, does protein increase muscle gain with resistance training? The answer is check, yes. It's really about leucine and about how potent leucine is in stimulating muscle protein synthesis. But you do have to go to the gym. You have to work out for this to happen. Does protein supplementation increase the amount of muscle that I gain? Check, yes. That's a very good signal. How much protein do I need? If you break this down on a per meal dose, the recommendations will probably be about 0.3 to 0.5 grams per kilo of body weight per meal, or between 1.6 to 2.2 grams per kilo per day. And I think that's a check. It's a pretty good, decent, strong signal. How does aging affect protein requirements? This is important because the globe is aging, our population is aging. Older people require more protein. And hopefully, if they combine that with physical activity, they could stave off some of the effects of aging and prevent frailty in old age. Finally, are some protein supplements better than others? The answer is yes, but it's dependent on the leucine concentration of the protein. Leucine is a remarkably potent amino acid that stimulates muscle protein synthesis, and that is a trigger for muscle growth. In fact, a lot of the studies that we saw really show you how important leucine is, and a lot of the other amino acids are simply there to provide the building blocks. As Dr. Bickman told you this morning, protein is a growth nutrient. And the last important point, and one thing to take away when somebody says to you, you know, protein causes your kidneys to fail, the answer is that's not true. There is no evidence to show this. And in the absence of evidence, you're left to wonder where this idea came from. I'd like to thank you very much for your attention. It's a true honor to be here.